Hey everyone, welcome to another amazing hands-on workshop from the Kubesimplify workshop series. So the last session, which was on observability by Manoj, got a lots of love from the community. So here we are catching up with that momentum. So today we have the complete Service Mesh hands-on with Syed Imran. Syed is an SRE currently working at 66 Degree. He's also a speaker, a mentor, and most importantly, Golden Cubesonaut. So over to you, Syed.
Hey everyone, it's pleasure to be here at Kubesimplify. Yep, things going pretty well. Hope you are having a great Monday too, starting a week, right? So yeah, a quick intro about me. Let me just my screen. Yep, yep. So yeah, yep. So yeah, hope people are doing good. So this happens to be my very first workshop on YouTube. Pretty excited, a bit nervous else, but yeah, I think I'll bring it up. Anyways. Yeah, before jumping forward, thank you so much, Cube Simplify, for having me, Sayyam, Saloni, and Pianshu, for giving me this platform for getting this workshop to a very widespread audience. So yeah, so a bit about me. I am Syed Imran. I am working as SRE at 66 degrees. I'm a Golden Cubesonaut for the persons who maybe don't know about Golden Cubesonaut. So it's a entitlement that is given to people who achieve the status of Cubesonaut by completing all the five certifications of Kubernetes, and then completing the other available CNCF certifications. So that gives you a lifetime entitlement of Golden Kubernetes. Apart from CNCF, ecosystem, I have six certifications on Google Cloud professional level, and I'm also a co-organizer for CNCG Bhubaneswar, that is in the state of Odisha. And I've been a speaker and mentor as well for lots of platform and contributing to the cloud native community. So it's been great so far. I'm looking forward to a very productive workshop, Service Mesh, and yeah, I'll be also looking into the if you have any questions throughout this workshop, I'll be happy to answer and help you learn to serve the Service Mesh, especially HT of course. Yeah. Cool. Yeah, so let's get started already. Yeah, so this happens to be the brief agenda of how things would go. There would brief about Service Mesh. What exactly is Service Mesh? Do we need it? Why it came in the first place? And then we'll kickstart with working with Istio. It will be pure hands-on workshop. Everything, all of it, what I'll be performing with, I will be handing over those entire scripts manifest all over to you so that you can go on parallelly hand on hand alongside me. In case anything shows up, if there's any issues, I'll be happy to just drop it in comments or in a live chat so that I can pick it up and answer your queries. Right? So we'll be deep diving into the traffic management part of Istio, right? Of what it does beyond native trafficking of Kubernetes. We'll be deep diving into security as well. Some of the Istio native features which makes it unique from other service meshes. We'll see about the what's like a brief overview of what observability Istio gives in terms of one of the known service mesh. And uh, the my favorite part again is the multi-cluster networking that I'll be going through and setting up the multi-cluster, and we'll be seeing the cross-cluster traffic going between the two clusters seamlessly. Yeah. Then we'll go for troubleshooting, like a bit about how you can troubleshoot with Istio once it's up and running, and you have issues configuring Istio for your use cases. Then yeah, we'll have Q&A. Of course, we'll be having Q&A then and there whenever you feel can have it in the comments. So yeah, I'll be
Sure,
happy to
sure,
pick that
sure.
up.
100%.
Cool. So let's get started with the first part, service mesh introduction. So service mesh is a dedicated infrastructure layer that manages service to service communication in a microservice architecture. When I say that, a dedicated infrastructure layer. So when it comes to deploying a highly scalable microservice based architecture, no matter if it's in Kubernetes or if you have any other orchestrating server, the heaviest part of configuring this microservice is the networking part. When, when and how does this microservice communicate? Right? So there comes the service mesh, which helps microservice. It becomes an abstraction layer. As a developer, you need to manage the service to service communication, like having mTLS or authorizations in place. Maybe you want to perform A/B testing. Maybe you want to have Canary releases. Right? So all this is possible when you inculcate service mesh onto your infrastructure. It acts as a transparent and configurable way to handle traffic routing, security, observability, and other network concerns. Definitely, we'll be going through each and every, you know, uh, tactic words I mentioned about security, observability, and we'll see more about like what this service mesh actually does and how it came to this. So yeah, these are some of the open source service mesh, Linkerd, a lightweight, simple, and ultra fast service mesh focused on ease of use. Istio, the one that we're gonna learn today, a feature-rich service mesh for advanced traffic management, security, and observability. CDM, which people usually say it as a CNI, but it also has inbuilt service mesh capabilities as well. So these and some of them, like Submariner, is one that is from Red Hat. It is also one of the service meshes. It's open source. Yeah. So first question: do we even need it, mesh or mesh? The reason I've mentioned the second mesh because with a service mesh into this ecosystem, it creates lots of controls and plugs which you can switch and change. And if given it's not in proper way, it would really end up in a mess, right? So do we even need it? So it's not like buy and bola karne ka to karne. I use like a startup CEO that just has a fancy term and just wants to implement, right? No, it's not like that. Just kidding. So during this entire workshop, when you go through the this all the scripts, all the possibilities the service mesh brings into your infrastructure, you're definitely gonna have you will have an answer to that. So yeah, I think we are pretty good to get started with Istio now. And before getting started, I would okay, the latest slide. Ma'am. So a brief intro about Istio. It challenges the issues that developers and even the DevOps admins face when they are supposedly deploying a distributed microservice-based application, uh, you know, over Kubernetes specifically, because again, if it's your it's the Kubernetes it is what running on, right? Do you face any issue? No. Yeah. So even if you're building something from scratch, right, or migrating any existing, monolith application which has been a legacy application for quite some time, it's still like, it fits the same purpose of doing it. Right? It ensures that cloud native and distributed systems are resilient, helping modern enterprise maintain their workloads across diverse platforms while staying connected and protected. So there has been lots of use cases of service mesh and specifically Istio that has been helped a lot of not just being native to Kubernetes, but uh, use case that I would mention was to migrate a monolith application that had been running in a chunk of a server to just to make it more scalable. Istio falls a very good use case in that basis as well. Okay, yeah. So yeah, we I'm just gonna give an overview of how it held like at the end of this workshop. But yeah, some of its use cases definitely we're gonna have it in this workshop. So Istio has two operation modes, like on how you're gonna deploy Istio. It works on two of the modes, the sidecar mode and the ambient. So in the sidecar mode, it's pretty self-explainable. It runs a container, an Envoy container, which on which the entire Istio is built up. Envoy is an open source proxy management, I'd say, software or open source software, whatever you can say. So it deploys a sidecar, a container which is parallel to running parallel to your workloads. Given you have maybe deployed a very small scale e-com app wherein you are running maybe cart, auth, product, all of it. And so what happens is Istio injects its own Envoy containers into these pods running parallel to your workloads. And using that, it is able to push the configurations and the traffic that goes in and out of this workloads is first this goes through the layers, I would say layers, or maybe you can say it is the very first container. I mean, the Envoy container is the one who receives the traffic first, and while leaving as well, it is the Envoy container that monitors this traffic. So that's what the sidecar mode is. And the other mode, the ambient mode, is a bit, makes it, I would say, won't say complex, but the architecture changes from one extra container per pod to one pod per node, right? Given if you are running, let's say 10 pods per node, instead of running 10 more containers per pod, it would run just one pod per node. So, drastic difference is what you see here. So running again comes people again, a bit mention about the drawbacks of running one container per workload is very, very hectic, on the resource usage part. Again, it comes with a cost as well. Of course, you're running some resources. The cost is something you need to be very concerned about. But given the use cases, I would say it's pretty lightweight, and the features that it provides, of course, that is what the trade-off is. Anyway, so the entire workshop is primarily like entirely based on sidecar mode. Ambient mode is something I'm not really going to mention more about because it's completely a different topic at all. So the entire nature of how Istio operates changes a lot. So this workshop will be completely focused on sidecar mode. Okay, maybe in future we can have another workshop on ambient mode, but yeah, that is something I just wanted to mention. Okay, so overall the architecture of how the Istio architecture is. So the way Kubernetes also operates, right? You have a control plane, you have a data plane, right? The control plane is like the brain of the entire cluster, and it monitors, it orchestrates the entire life cycle of Kubernetes. A similar architecture, but in a different way. Here also we have a control plane and a data plane. So control plane consists of three components. In earlier releases of Istio, these three components that you see, the pilot, the citadel, and the galley, uh, they used to run in a complete different isolated pod. So that created more complexity, right? So eventually they merged it into one single unit, which runs as Istio daemon that runs as a one single pod and manages all the functionalities of pilot, citadel, and galley. So let me quickly walk through what each of them are responsible is. So pilot uses Envoy API to communicate with Envoy sidecars in running in each of the workloads, alongside the one container that Istio injects, right? And it is also responsible for the traffic management. And Citadel provides secure communication between service by managing user authentication, certificates, and credential management. And Galley is responsible for configuration management, distribution, and processing. So these three collectively run in one single container, Istio daemon, right? And it serves the purpose. If you can see in this diagram, the service A and the service B, if you see there's one extra container running alongside that pod, the proxy container, which acts as the data plane for the Istio service mesh. So, yeah, um, do we have any questions regarding so far related to Istio? I think it's pretty similar, simple and go through of what exact, this entirely is from Istio documentation itself, just to make it, very easy to get started. Cool. Moving forward. So there are some components of Istio that I wanted to, make sure people are aware of because this are going to be used in the workshop. Okay. So just like if I feel everyone must be aware of, Nginx Ingress gateway. Uh, could I be more specific? Is L3 or L? So each of the components of Istio, they work at different levels. I would say if you ask me about Ingress gateway, so it comes from layer 3, and there are some components through when it goes to gateway, then virtual service and destination rules. Each of them play a different role in L3, L4 as well. Okay. There are authentication policies which work in L3, L4. Ingress gateway works in L7, right? The one the traffic is coming into the cluster, right? It's pretty similar like what we had earlier, right? The Nginx and Ingress controller, which has been completely, as I would say, deprecated, and rather not being continued to be managed anymore. So yeah, so Ingress gateway is something pretty similar. The name itself also suggests a lot. Like it is the like component which receives all the incoming traffic to the cluster, the way we had Nginx Ingress controller. And the next one is the east-west gateway for, so this gateway is specifically for multi-cluster setup, wherein the data, I mean, I'll say data, I would say traffic, it traverses across clusters, enters, is basically entry point for any traffic that goes in and out from the cluster. So it's the east-west gateway. Egress gateway, again, the name says it out. So it is not a mandatory component, but could be useful where we want to, you know, maintain, I would say, want the traffic to go through a given path. Suppose if the microservices are communicating to any of the external API endpoints, and you want that traffic to go through a given, network path. So wherein this is where you want egress gateway to be in place. Right. Mm. So yeah, that's pretty much about the three gateways that we're gonna just, yeah. So that was pretty much about the gateways that I wanted to mention. Egress gateway is something we are not looking forward to for this workshop. Again, it will stretch more of a time. But Ingress gateway and Istio gateway is something that we'll definitely use it in our workshop today. Okay. So yeah, there comes the part wherein we'll be working through,
Yeah, say there's also this question.
okay,
Yeah,
is okay. L3, L4, or L7 base. So Istio majorly it operates at L7, but given if you manage the traffic, when it comes to advanced use cases, so that would definitely also go through L4 if I'm not mistaken. Will the sidecar increases latency as opposed to communication happening between different directly? No, it won't really do that much of a thing. I mean, if it won't be noticeable difference, but of course, uh, as it is a very lightweight container, I would say. So it just intercepts every traffic that comes and goes through. Given if you want to, if you're implementing any sort of configuration on it, but still it wouldn't be that sort of a thing that you would notice a downtime or maybe a latency in your application. MTL, how MTL is managed here, like where we, okay, so it is part of the workshop, of course, but I'll just brief it out. So MTL is something completely managed on Istio side. So when you kind of, I'll say enable sidecar injection. So this Envoy container that runs as part of the data plane, it is the one which manages all the certificates. So you need not need to make any certificate configuration. You need not need to be aware of how the certificates are, injected or rotated events. All of this is maintained from HTOD. So it injects the containers, and the containers are the ones who intercept traffic among whatever traffic comes and goes. Right? Okay, so examples of service measure. Okay, so okay, uh, so there's a question about my preference when we choose between service meshes. So given here it's more about the use cases. So if you compare features of each and every this service mesh, given it's a linker, Istio or CDM, maybe others are as well there. So it pretty much depends on the use case. I would say if you want a eBPF powered service mesh, which gives a very good deep insight of how the containers are running, or you want CNI and service mesh. So yes, CDM would be perfect one for this use case. But if you want very feature rich service mesh that goes beyond just managing the the internal traffic, but also manages, as mentioned, mTLS, and gives an inbuilt observability without touching much into code. Yeah, Istio is one of them. Linkerd is much more lightweight. I'd say if you are experimenting with service mesh and you want to like go forward and implement it, I would say Linkerd would also do good. Yeah, it's pretty lightweight as compared to Istio. Uh, for example, we have finance-related applications deployed done in multi-cluster environment like three master and three workers. Which gateway will be preferable? Okay, so Jagdish, I'm not sure about the use case that you're mentioning. So each gateway serves a different purpose. So Ingress gateway is primarily like the only, I would say, responsible part is the incoming traffic, the way we had for Nginx Ingress controller. So that is what the Ingress gateway is for. And for East-West gateway, so you need to be configuring East-West gateway for performing any such action. You deploy it and then configure the Istio daemon to make sure that it is well aware of the traffic that is supposed to go between the clusters. So if the traffic is traversing between the clusters, then it is the East-West gateway. The traffic is coming from maybe a completely different. Maybe a user is accessing the application, right? In that cases, Ingress gateway is the one which is the component being used here. Mm, Why east-west traffic requires gateway object? No, it doesn't. East-west traffic doesn't require gateway object. So the ones that I mentioned, right, those are actually running pods. They are not objects. Just to mention about it. So definitely we're going to see more into when we go into the workshop. Mm, Yeah, Augustine, we haven't really started the workshop. I was just briefing about what are things in Istio and what are components are there. We are perfectly fine with starting the workshop. There's absolutely no issues. Storage, failing service, how do we prevent? So there is a max retries, I would say configuration in the gateway object that you can keep it as the max retries that you really want to happen. And we also have the provision of circuit breaking, right? So even that is something I would say could be useful in your use case. And sidecar will require a condition between proxy and the service. Mohammed, sorry, I'm not able to understand. Maybe if you could be more specific, I can answer that. Yes, Dhaka, definitely. We're gonna see the entire thing. So it's a workshop, right? I have a repository with me that I'll be, sharing it with you so that you guys can also, implement the same that I'm gonna walk through. Good. Let's get started. Okay. So what I want is basically, let me also make sure that it's the right repository. So you just open uh, yeah, that's the right one. So please go ahead and clone the repository and just give me heads up in the comments that you have the repository cloned in your local. Okay, then we would be good. I already have it, of course, in my local. We are pretty good with the background knowledge that I wanted everyone to be well fetched with. And yeah, we are pretty much on the schedule. Please give me heads up if you are able to clone the repository in the comments so that I can move ahead with the execution. Yeah, thank you. Thank you, Sriram, for the link. A quick heads up would be good if you're able to clone the repository. I'll just wait for a couple of minutes just to get a confirmation, yeah, if the repo is accessible. Thank you, Sai, for the acknowledgement. I'll just wait a couple more minutes and we'll definitely get started. You. Yeah. So once you're done with the cloning of this repository in your local, so one of the prerequisite that is needed as part of having this workshop hands-on on your end is to have Docker in your system. And if you're running on Windows, make sure you have WSL at your end because all of the commands are Linux-based commands. If you're on Linux, great, absolutely no issues with that. And Mac system would also be absolutely no issues with, given you have Docker. Okay, Docker is something I would say is a needed requirement. In case if you don't have it handy, you can definitely go out and install right away. Anyways, as you have the repository with you, if by any chance if you're not able to go ahead with, yeah, you have it with you, the entire repository of this workshop. Yep, cool. So we'll just get started. Moving ahead. Uh, Wind, I'm not really sure because the only part I feel may would fail is the multi-cluster part. Apart from that, I think everything else should work fine. Yeah. Because the reason I'm using kind is, I mean, pretty much fairly, easy to configure and spin up a cluster. And yeah, so the traffic management part and the traffic shifting part, I feel that should work absolutely fine with you. But given if it's a multi-cluster thing, I think it would not work because I'm using a bit of a custom script wherein some IP manipulation is done, just to simulate that there are two complete different clusters and the traffic goes in and out of the cluster. So that part is something I would say not work. Cool. I think pretty much quite some people have cloned the repository. Let's move ahead. So these are some of the traffic management features that Istio supports: request routing, fault injection, traffic shifting, circuit breaking, and traffic mirroring. So request routing is pretty, I'd say, simple to explain that the way Ingress objects worked, or maybe the gateway object itself works, right? You have a given path, you route it to a given, I would say, microservice. You want header-based manipulation, that is also possible, right? This is what request routing. I'll just brief about everything, then we'll kickstart with the practical part. Okay. So yeah, and fault injection. If you want to test the resilience of your microservice-based application, you can have fault injection in place. Traffic shifting. If you well aware of the this Canary release, and maybe you want A/B testing. A/B testing kind of what is traffic mirroring is. But if you want a canned release or a blue-green deployment, right, this kind of thing, if you traffic shifting is what help will be able to help you out. Circuit breaking, as I think already mentioned, if there is a service that is failing again and again, we can easily implement circuit breaking and prevent the application from going down completely. Traffic mirroring, of course, A/B testing. So maybe releasing an application, you want to test that the incoming traffic, any feature that you're releasing very, it's critical and you are very not much confident either it would work or fail. So what you can have is a traffic mirroring. So the traffic goes both to service A and service B. So once you're confident that the new feature that you have rolled out is working perfectly fine, then yeah, you can have the mirror down and all the traffic goes to the new release. Right? So for this workshop, I'll be going through request routing, traffic shifting, and traffic mirroring. Right. I think I'm pretty good. Let's get to the IDE. So we have 6 folders here, each for its own topic, of course. Intro is something I pretty much missed. Apologies for that. So let's go to the intro folder. So I have this anti-gravity ID here. I'll just close this agent. Don't need it right now. Okay. So each of the folders have a very similar structure of how I have organized this workshop. Let's go ahead with the intro one. So you go into the you cd into the intro folder, 01 intro folder, and I'll just run before running. Of course, I'll just walk through a couple of common manifests that I have. So in the infrastructure folder, what I have is the configuration for setting, spinning up a kind cluster. Okay, so this is what the manifest for client cluster is. And I have manifest for installing Istio as well. Okay, okay, even before that. So what also please make sure that you have the kind CLI installed in your system. Okay, if not, please go ahead right away and you'll be able to easily install kind CLI. Okay, and once you're done, you should be very good to start with post kind CLI, and you also need to have Istio CLI as well, Istio CTL command. I'll just post the link for installing Istio CTL. So you can, navigate to the Istio's official documentation page and straight away just install it. I'm also pasting the yeah, I'm also pasting the official page of Istio wherein you can go and download Istio Studio. A quick heads up if you have it installed in your system, Istio Studio. Yeah, that should be fine. No worries with that. Kind version is 20. That should work. Yeah, perfect. Please go ahead and install Istio. I think 1.30.2 would do. Yeah, you may not need to have the latest one, but 1.30 is something I feel it should be good to go with. Yeah. I'll just wait for an acknowledgement that if you're good with, so I'll kickstart. Tell me if you have any questions, I would be looking into it. Sure thing, yeah, I can do that. Increase the font size. A bit more should do. Yeah. No Istio link. Don't proceed ahead to this link and please download it. Oh, thank you, Vishnu, for the acknowledgement. Make sure you are able to run, HTTL command. just make sure you're able to run this command and it shows, because there is no cluster running. That's why the error for the timeout thing. But yeah, you should be able to at least see the client version in that. Cool. Thank you. Thank you so much for the acknowledgement. Right. So for the people who are done with Istio installation part, so and also the kind is present, right? Even I'm not sure what version of I have. Yeah, I have 0. So kind version doesn't really shouldn't be causing any issues, because we mentioned the Kubernetes version that we have, and I have mentioned in the repository itself. That wouldn't be an issue at all. Okay. So yeah, so I won't explain the scripts. Of course, I would say it's fairly simple. So what I'm basically doing is I'm just installing kind. I mean, I'm setting up the Kubernetes cluster using kind in the script. Okay. So yeah, the scripts are fairly simple to understand. That's the whole reason have kept scripts, so that I'm not messing with commands, and there is not much of a communication gap for setting up these things. Okay, cool. So I'm in currently the intro directory. Okay, so what I'll do is I'll just go and run the script. Okay, so it will just spin up the kind cluster. Yeah, once the kind cluster is up, it will install using the istio install -f istio config. There is nothing but the part to this istio.yaml. So if I can quickly brief about this istio, YAML, is basically I have mentioned that I need Ingress gateway to be installed as part of Istio installation. And what I have done is I have given a node port of 30,000, which is basically pointing to the port 80 of Ingress gateway. The reason for that is so that I am able to, you know, uh, work or maybe hit the application that would be running inside the Kubernetes cluster through from my local machine. Because it's not I cannot have a load balancer here running, because it's a local system, right? So just to avoid any extra network related configuration, I'm basically making this node plus 30,000. And if you can go to the kind config, I am using the container port 30,000 to point to the host port 80. That it's easier for me to be able to hit the ingress gateway and then access the applications running. So yeah, yes. So if you can see, I was able to install set up the kind cluster, and then I have installed Istio on it with the Ingress gateway enabled. So now if I run the Istio Security version command, I should be able to see the client version, the control plane version, and the data plane. One proxies, that is nothing but the Ingress gateway itself. Okay. Let's check for the pods in the Istio system namespace. So as you can see, Istio the Istio daemon is running, and Istio Ingress gateway is also running. Okay. Yeah. Let me let me know if you have been facing any issues so far. If not, then we are good to go. Okay. 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 So the issue is, of course, now present in the system. So how does it work? So how does the sidecar get injected? Okay, and it's fairly simple. Okay. So what you just need to do is, suppose there you have a namespace in which you want any pod that runs in the namespace. You want the sidecar to be injected, which becomes the part of the mesh. Okay, one thing I pretty much missed mentioning. So what the mesh word basically represents the connectivity of the systems inside a network. Okay, that's what service mesh. It's mesh of the services, the workloads that you'll deploy. So that is what a mesh means. Okay. So when I say mesh, it's basically the entire connectivity network between the workloads that I'll be running as part of the service, I mean the service mesh. Okay. So, okay. So I was saying, so how do we enable this injection of sidecar, the data plane part of the entire Istio service mesh? Fairly simple. What you need to do is you need to just label the namespace as a default for me as of now, just for the demonstration purpose. To have Istio injection equals enabled. Okay, that's all you need to do if you want to, enable sidecar injection for any of the pods that you run in the default namespace. That's it, right? So the default namespace has been labeled for Istio injection as enabled. So moving forward, what will happen now is if I run anything, any pod, no matter if it's a part of you know deployment, daemon set, anything, right? The moment I run any pod in this default namespace, what you'll see instead of running one by one of one as ready, you'll see it's initializing as of now. You should see two by two. Reason being, one of the container, of course, the Nginx. The other one is nothing but the Envoy sidecar. So if I even go ahead and get the YAML of that, you could just scroll a bit. You should be able to see, yeah, just on the volumes. Yes. So yeah, this is the Istio proxy container, right? That runs parallel to your actual workloads. If you that was the Istio container, and this is our main container. If you see, there are two containers. One, of course, our workload that we ran, just the Nginx one, and the other one is the sidecar, the name with the name Istio proxy. Yeah. So that's how easy it is to get started with Istio enabled in your cluster, and that's how it's easy to enable Istio injection as well into your cluster. And before this question was up, how if there happens to be use case where you don't want even though you have enabled this Istio injection in the entire namespace wide, if you want a given workload to not have Istio injection, so for that as well we have annotation at pod level. In the deployment manifest, you need to have this annotation of sidecar. Uh, Let me just search in this repository itself. Yeah, so this happens to be the annotation that is to be present in the metadata of the pod in order to avoid issue injection if it is enabled namespace wide. Okay, so that is the annotation that you need to have in order to avoid injection. Sidecar. Okay, so far so good. Do we have anything concerning or any questions so far? As given we have already started with the workshop. Yeah, if I will take it as a no, good. So yeah, so for each of this folder, right, what I have done is I have a complete script of spinning up things, configuring, and then removing it off completely. Just for this, I really want to run the command. Maybe you have done missed it. So to clean up the entire cluster that we have set up, just run find delete clusters and it should be cluster one. Okay. Make sure you clean this up because the other, this setup has lots of different changes. I mean, lots of different other configurations, so it would collide with each of part of each of the modules of this workshop. Yeah, just to make sure you delete it. The command to delete is find delete clusters. That's it. Straightforward. Good. Okay, I think we are good to start with the fun part now. So this was fairly an introductory one to just, how do we have Istio spin up and running, and how do we enable Istio injection, right? Moving forward, I won't be explaining that part. I will be just deep diving into exact concepts itself. Like if you open this second directory, the traffic management, we should be able to see request routing, traffic mirroring, and traffic shifting. Okay. So yeah, let's get started with request routing first, of course. So it was fairly simple as any Nginx ingress that you have ever configured, but instead of configuring ingresses, here what we have is gateway object, but not native to Kubernetes, rather to Istio, right? So as gateway API and gateway API object, the new normal that we have for configuring traffic even before it was into place, when Ingress was at being used commonly, Istio introduced its own gateway object API, using which we'll be first defining the entry level of traffic. Then comes a different API object which is native to again what I say Istio itself. It's the virtual services. Then again there is a differentiation. Okay, so let me put it this way. So the entire network traffic that comes in, or it goes within the mesh, has been decoupled and maintained through different object APIs of native Istio object APIs. One of them is the gateway API object. Second one is virtual service. Third is destination rules. So we'll see each one of them. So I haven't pasted it, I mean, any content related to that in the presentation because it's better to have it in YAML itself, and it would be easier for me to explain in the YAML itself. Okay. So again, it's a common part, the infrastructure part. It will just spin up the kind cluster. It will set up the Istio. Like you see, if you could see, it's pretty much exact what we had earlier as well. So not much of a thing to explain, and kind as well. And here we have some. Okay. Oh, right. So in the manifest, if I show you, so there are some deployments. Okay. So again, this will be the entire part of this. So these are the deployments. I have created some sample workflows. I mean, some sample workloads to demonstrate this use cases. Okay. So what I have here is a very simple movie application which runs a front end and a back end, and it fetches uh, Hollywood movies and Bollywood movies. Okay. Depending upon, of course, some configuration. It's fairly simple. I won't be explaining how I'm deploying this because again, Kubernetes is something I'm not going to explain right now. So yeah, so it has a front end and two backends. One serves Bollywood data and another serves Hollywood data. Okay. So what we're going to see in this traffic management is, so let me just show you. Okay. So this is the gateway API object of Istio. You can see the API version, it has Istio. So I'm gonna deploy everything in the request routing namespace. It has a selector the way we have for gateway API object native to Kubernetes. We have the port. So this part is what pretty much same to what we have in gateway API object. Right, it's pretty similar. I have kept host as star, of course. It's for local use case. Even if you want to have any dedicated domain, yeah, you're most welcome to edit it, of course. Then, as I mentioned, once the, the incoming traffic comes from Istio gateway. It is handled by this gateway object API. Then comes a virtual service, which references this gateway to be the incoming traffic. So this virtual service is basically the next entry point post the gateway API object. I feel this point everything is fairly self-explanatory, but I'm gonna explain this very peculiar part. So if you can see, I'm uh, using the API prefix matching to make it land on a given service. So it's slash API. But what I'm also doing is I'm also checking for a header. How have you? No, Vedanta, I have not touched ambient in this one. Definitely next time, of course, the next workshop, but this is primarily everything with sidecar itself. Yeah. So what I'm doing here, so the header, right? I'm looking for an header X user, which if matches with, this beta, I want to rewrite to slash and make it land on movie backend with subset v2. Again, what's this part? What is this destination? Right? So as I mentioned, the traffic comes through gateway, then virtual service, then it is mapped to destination rules. So in this destination rule, what we basically do is we group, just to make it simple to sound. What we are doing in this destination rule is, given this is the host, you know, the resolving part, the domain resolving part of what I'm saying. This is the host that needs to be resolved. We are creating two subsets depending upon, I mean, basically on it, kind of a label selector is what we are doing here. So if a given workload resolves with movie backend as host and has label as v1, we're gonna have it as a subset of v1. Sure, I can increase that if Ibrahim, just to mention, I've already also shared, the link to the repository. You can have it cloned in your local and also can see it in the same path wherever I'm presenting this workshop. So you can work on alongside to have this workshop. So yeah, I was saying, so this destination rule basically defines or maybe groups out workloads depending upon labels over here and giving it a name of v1. So suppose I'll present it this way then. Suppose we have two deployments running, each with the similar spec, but some configuration changes. Maybe it's a new release. So what we're gonna do is we're gonna label this new release as v2 as a version 2, and we are gonna make it as a subset 2. And for the existing one, the label v1 and the subset is v1, of course. So here, once this grouping is done, then it is the virtual service wherein we can mention, right? If you can come back here, I have mentioned over here that if a X user has sorry, the request has X user and it has beta in it, I want that traffic to land on movie backend host, of course, but on subset v2, right? So that is basically the new release, the new workload that you have. That is what this particular request will land. Apart from that, if you just have the slash API, implies you don't have this. So if this doesn't match, so what's next? So if it matches with just slash API and doesn't have a header, I'll just make it land on the V1. Okay, that's what this virtual service does. Okay, fairly simple, very easy to understand. I'm resolving it for all of the hosts because again, yeah, this is for local system. I'm using the Istio gateway that is already explained over here. This is the Istio gateway, and the destination that I've mentioned in the the virtual service. Yeah, this route is what we are defining. I mean, which all subsets to land with this labels basically, right? V1 for version V1 and V2 for version V2. I hope that's pretty clear. Right, so we're gonna see it live right now. Okay, let's go to the traffic, 0 to traffic management, then to request routing. Okay, here also I have you know single run scripts handy over here. So this is the one to deploy. I'm not really sure about that watch again. Yeah, okay, hope that resolves for you. Okay, so I'm just gonna move ahead and forward deploy the entire system. Okay, it gives you money-driven architecture that's fairly easy to understand and run through. I'm just gonna go through and just deploy all of it. Right, it will take a couple of minutes maybe for you. Okay, get it up and running. Just wait for some time. So the kind cluster is up and running. Now it's gonna install Istio on it. So that part, so the part of setting up kind cluster and Istio is pretty much similar in all of the modules. Yeah, just because some configuration changes across the cluster. To have a fresh start, what I'll be doing is I'll be cleaning up after every demo. That will be easier and you know very free of conflicts across the demos. Okay, for each of the demo, I'll be creating and destroying the cluster. Yeah. So one thing I wanted to mention was, so this application basically requires a TMDB API key, but not necessarily for this demo itself. In case if you have one, absolutely fine, go ahead and paste it. If not, just enter any random character and just do enter. It's not a hard requirement for this workshop, but for the application to work full-fledged, you need to have it. But it again, it's not a required thing. Okay, fine. I don't think so that's a immediate thing, but yeah. Let me check in this. Oh, to comment this out. Okay, so there's a small issue with this script. What you need to do is you need to, you know what? I'll just make it. I'm not sure if I'll be able to push it from here, but yeah, what you can do is you need to just comment out this, or maybe completely remove this part of manifest base config.yaml. This is something maybe I would have missed it. But yeah, please make sure you remove this because it's stopping from creating other. You know what? I'll just do one thing. Just give me a moment. I'll just push my changes so that you can just make a pull and yeah, you should be good to go. Just a moment. Yeah, just do one thing. Just take a pull on the same code base, so you should be good to go. And just go ahead and deploy this. Okay, let's do just manually run this. So it was able to create the movies backend destination service. The only thing remaining was this. Fair enough. Yeah. Just let me know if you're able to run this script or you face any issues. Yeah, make sure to, of course, pull the new changes. Mohammed, I start phase one with kind example, disable default CNI. No, I think there shouldn't be any issue, Mohammed. I think that should be fine. But yeah, if you can, just go through with the flow, that should be better. If you have any issues with the default CNI, please, is there any issue with that? If not, then yeah, just go ahead with that. Because the only thing that we'll be needing is, I would say the Kubernetes cluster, no matter if it's a managed one, I mean, if it's local system, if it's a GK, EKS, no matter of that, it should work. Yeah. Okay, I'll be proceeding ahead with the demo part. I've already waited for quite. So as you remember, what we did was just went ahead and ran this deploy script. It had some issues, but yeah, that's fine. It's we're good. So what it did basically was, let me just take you. So it deployed the backend, two of the backends, V1 and V2, and one frontend. Okay, so as I mentioned, the V1 basically serves the volume data, V2 serves the Hollywood data. Okay, and if you remember the virtual service, what I did was basically, and depending upon the header value, I'm basically routing the traffic, right? So let's go ahead and see how the application looks. Let me just present a different screen. Okay. So I'm running on a local machine, so that's why I have the domain. Okay. So yeah, if you can see, this is what the application look like on the home page, right? So by default, all of the requests lands on V1. So this is if you reload, it will just keep updating a bit. So yeah, you can see the application. But so I have this extension from Chrome, which is modify HTTP headers. Okay. So what I'm gonna do right now here is I'm gonna use this extension, and what I'll do, I'll just pass X user as the header and beta as the value. So when I've enabled this, what I'll do is I'll just come and reload the page. Okay. So now I hope you're able to see the difference. Now what is happening for the entire application has changed. So I mean, not as in visually, but the data that comes from the backend, now all of that data is routing to the Hollywood backend, not the Bollywood. Okay. So if you can, even after I'm able to continuously refresh, you can see all of the Hollywood movies. Again, if I come back and just disable this, so if I reload now, of course, we would see Bollywood movies. Right? So this is what I was mentioning, the request routing part. It's fairly simple to understand how an Nginx, ingress or maybe gateway object API would work. Fairly simple to understand. Header-based manipulation. Yeah, if I give pass and header, the entire app flow changes. Right, that's how it is. Right. So use cases, of course, if you want to, you have a beta set of users wherein you don't want the application to be down, but only beta users to land on a given version of application, right? Beta testers. The way even we face, right? We when we open WhatsApp, sometimes it may so happen that given person has a different interface of WhatsApp or given, but you have a different one, right? How does it work? Of course, not. It's not that simple. But this is something very similar that happens, depending upon headers or maybe some keys, maybe some sort of auth value that can take place, right? So what I could have done better was instead of just passing just a native value, maybe I could have passed the token itself. So that token decodes and given if something, there's a different value to that, we can route it to a different, backend. That is something really possible. We do have it handy in the workshop. We're gonna see that, right? Cool. I think so. That's the part of request routing. So I'm gonna go ahead and clean this up. So that's fairly simple. How do I do that? Script clean all. Yeah. Once you're done with the demo, I just go ahead and clean out. Oh, that's fine. I think again the config map issue. Let me do one thing. I'll just move all the. Not sure why this flag doesn't go. Just let it manually. Okay, so okay. So I've done a permanent fix to this. Yeah. So I'll just request you to please take one more pull where I have removed all the occurrence of this config map. Uh, there shouldn't be any further issues anyways. Yeah, so that was the part of request routing. Now we'll go for traffic mirroring. Okay. So what's different in this? Of course, I feel it's self-explanatory. So let's take in scenario where you already have V1 application with Bollywood movie serving. Maybe you're releasing a new feature with the Hollywood data, and you don't want the public to see it right away, but you want to see how the application performs with the live traffic. So what will happen here? One single request, it comes, but it lands on both the services. Okay, so let's go through the manifest of virtual service. So the gateway, of course, remains the same. Absolutely no change in that. Exactly the same, right? Even the destination rules stay the same. The game changes where exactly is it's in the virtual service. Okay, so let's understand this very specific part. It's fairly a simple change, but yeah, that's the game. So what I'm doing here is I'm mirroring the traffic which lands on subset V1 to also go to V2, and I can also manipulate configure the percentage of traffic that goes to V2. Okay. So what we'll see that although we are seeing on output as V1, right? I mean, we're seeing the volume data, but we'll also see if we check the logs of the V2 backend running out there, we may see we would also see traffic coming to that, but the response is not getting to the front end. Okay, so that's what the traffic mirroring part is. I would say A/B testing can be done. So this is what A/B testing is. You get the traffic also to parallelly to a non-live workload. Right. Let's go ahead and I think even this should constitute the config. Let us deal with that. Okay. Yeah, sorry for the inconvenience. Please make sure you perform the pull. I have removed the config mapping from the entirety of this repository, so you shouldn't be having any issues. Please go ahead and take a pull into the same repository and post that. Yeah, you just go ahead and deploy. Yep, it asks for the minute-driven part, and I'll just go ahead and deploy everything at once. And then we'll wait. Yep, again, to ask for the key, I'll just enter some random words. It's fine. You don't need it as part of this demo. Yep. Okay, so we are good with the deployment. Right? So let's go back to the console and refresh. Right. So as you can see, now we're seeing the data only for back. I mean, for the Bollywood data, the V1. Okay. I'll just refresh a couple of more times and we'll go. Okay. I'll just open another terminal and I'll show you that V1 has some traffic. Of course, that is where we're landing, right? I did 5 refreshes. I have in the V1 logs here. So let's go and check for V2 as well. Let's see if we have any traffic. As you can, it is also going to V2. Exact 5 counts, no less or nothing more or less than that. The exact count, right? 5 times. Right? If you want, what you can do is I'll just split them. Yeah, I have it. So this is the logs for V2. Just put an F. V1 hyphen F. Okay. No new data over here. Nothing, you know. Okay, so what I'll do, I'll just refresh once and we'll see that the traffic is going to both the clusters. You can see it went right away directly to both of them. It's not like it's, even the caller is the same, right? Yeah, you see? So that's how traffic mirroring works. So one of the key component of service mesh, and we can perform easy A/B testing using this, right? Cool. Just wait for a minute. If any of you guys are able to implement it. I'm pretty sure it does the same thing. So there is a script to event test, the test, I mean the setup as well. If you choose the fifth option, so it will just hit the live one, and it will also show that things are working. So it's a good validation in case. Uh, Balu, I'm not able to see your error. Maybe I think you must have missed the taking a pull of the script. So I have made some changes in my local. Maybe if you can paste that error that you're facing. Yeah, exactly. So you just perform a git pull in your system right away, and please go ahead and run it. Yeah, that's a config map that got missed. I mean, I had to remove it. Post once you take a fresh pull from the repository, you should be able to run it. Okay. So you need to set up monitoring on the new workload itself. Okay. So diagnosing part is something that you can set up. Okay. So the traffic mirroring part is what Istio is doing right now. Okay. Maybe you can configure some observability around it so that how your application performs. So what I'm trying to present is that the mirroring part is something that Istio is doing right now. The diagnosing part is something that is not being performed right away. Right? It is something that you need to set up, of course. And you'll see from the logs, maybe you'll be able to see the matrices, right? How is the application performing, like resource usage, right? All sorts of observability that you can put on with that, right? So yeah, that is something that you need to be configuring, right? I think we are pretty good. I'll just exit the script and I'll perform the cleanup again. Fairly easy with the command itself. So yeah, and yeah. So as simple as the cleanup was. Yeah. So do we have any questions so far as for like related to workshop, any configurations that you're missing? Ahead, we'll be jumping to traffic shift. I'll just wait for a minute or so, then I'll move on with the next. Canceling messages. Uh, I'm not sure about the mirroring part. I'm really not in depth with that. But yeah, it does have a service mesh in it. And I mean, the major purpose of having Cilium is the very part you mentioned, eBPF. Okay. Apart from that, I think it has multi-cluster, setup as well. But mirroring, I'm not really sure regarding. It should be possible. Hmm. I think it should be possible. Yeah. To Cilium as well, I pretty think it should be possible. Yes. Can we? Yes, Mohammed, that should be possible. That is one of the known use cases of having a hybrid connectivity. But so if there happens to be connectivity from your on-prem to any of the cloud, definitely Istio can sit in that use case wherein you have connectivity crossing boundaries, yeah, going to cloud and maybe coming from cloud to your on-prem. That should be possible. Okay. So yeah, this is my local machine. Yeah. So I have a DJ Spark machine in my local system. That is what I'm running. Uh, how do I? Yeah. So that's right. So if you are, I was running. So this entire application is what I'm accessing locally. That is what dot. If you can see the dot local. All my system, whatever I'm doing, is everything like locally because that's the whole point of having this workshop, right? So that I can without spinning up Kubernetes clusters on cloud or maybe even in an instance, I can have this land at your like being able to learn from. Cool. I'll just go ahead to traffic shifting. So let's see what's different here. Infrastructure part remains exactly the same. Manifest under Istio. We'll see you have virtual services. Okay. So traffic shifting is basically like basically turning the knob of how much percentage of a traffic would land on a given version of your application. Okay, same similar setup what we have here: V1 backend, V2 backend, and one frontend. So turning the knob is basically determining what percentage of traffic. So if I can show you right away, if you can see, so it's just the weight that I'm gonna knob like turn it like a knob, right? Everything apart it remains precisely the same. The host, the gateways, the prefix. Okay, so this is where the traffic change happens. I change the weight. Okay, one more very important thing and pretty obvious that the combined weight, after addition shouldn't not exceed 100. Fairly simple to understand, right? The percentage, it cannot go beyond 100. So initially, so I have this, case driven, as menu driven script running, right? The deploy. I'm using that itself. I'll be able to turn the knob and, we'll be able to see, but visually we may not be able to see that clear that all the requests are suppose I have 20 and 80 as weight, so maybe we can see the majority of the request lands on a given uh, version of the application and the lower goes to the other. We have scripts in place, so we can get a good overview of that. Let's go ahead and yeah, in the script and just so I'll just first deploy all the resources by choosing the option one. Let's wait for a while. Ask for the key. I'll just enter key. Okay, you can see setting initial traffic 100% to V1. Okay, so what we're gonna see is entirety of uh, the traffic lands on the V1 back. So no matter how many times I refresh, I would be seeing only the Bollywood movies, not the Hollywood. Okay, so just me pretend and to continue and just present. Okay, so now let's go back and see this application. Okay, I'll just refresh for a couple of times. Okay, I can see all Bollywood movies as cartoons as well showing up, right? So yeah, every time it's the Bollywood movies. So if I go back, what we'll do right now, we'll choose option 3. So what will happen? 80% of the traffic goes to V1, 20% of the traffic goes to V2. How is that gonna happen? I'll just apply this virtual service. That's it. This is the 50-50 one. Yeah, you see, 80% V1, 20% V2. Yeah, let's go ahead and choose the option. Yeah, it got changed. If you want me to, let's confirm from here if I can. Bollywood, Hollywood. Yeah, see? So again, of course, given if it's a huge number of attempts, you should be able to see the 80-20 percentage difference. Right? Bollywood, Bollywood. So it's pretty much random. Again, the Hollywood showed up, right? So that's how easy it was. Just by changing the weight, we are able to manipulate the traffic with weight, distribute, and balance. Yes, Mohammed, exactly. So it's just the weight that I am playing with. That's everything what we have seen so far in request routing traffic mirroring is this, right? It's the way that I'm playing with. So what I'll do is I'll just right away, let's go 50-50 first then. Yeah, let's choose the option 4. It changes to 50-50. Let's see. It will be pretty much random. It's not like one refresh comes Hollywood, one refresh comes Bollywood. It's not like that, but you would see a difference. See Hollywood, Bollywood. It's pretty random, right? You cannot expect every time to like proper load balancing is what you won't see here. Okay, again, it comes to if a given live scenario, if there's thousands of traffic, roughly 500 of 500 will fall on Hollywood and 500 on Bollywood. huh? So but you do see that right that there are some Bollywood movies still coming up and some Hollywood movies still coming up. What we'll do again, of course, we'll change completely to Hollywood. So of course, what we'll see now is zero Bollywood movies showing up. No Bollywood movies coming. So as simple as that. We're changing the weightage for V2 to 100. Of course, there is no Bollywood. There is no traffic now going to V1. So this was more like Canary release what we do, right? I've also a detailed article where we can use Istio and weighted routing, right, uh, to perform Canary release pretty much very automated. Okay? And you can just go to my Medium profile and you should be able to get it up. Yeah, there's an open source tool called Flagger, which in integration with Istio. So the manual part that I did, right, I was manually updating the weights, and then the traffic was shifting. So Flagger is a tool which can automate this very part of instead of you changing the weight, depending upon the success rate of the request count of success, it eventually lifts up. You can of course define all these parameters and how much percentage you want to increase. What should be the success rate you need to see in order to increasing those the percentage of traffic to the new workload. All these things can be done fairly easy. I'll definitely be sharing that post this completion of the workshop. It's very fun to try that. Yeah, that was pretty much it. Let's also run this generate traffic script. Let me see what it does. Just checks if the traffic is being split or not. So what it did right now is basically it spinned up, a load tester, which will be continuously hitting the URL of backend to check if the data is, the traffic is eventually getting distributed as per the weightage. That's pretty much simple. Can go ahead and play with it and make changes as per your use cases. What I'll do is I'll just perform the cleanup resource. Now I think we are done with the traffic management part, wherein we saw request routing, fairly simple, like any other ingress object. Traffic mirroring, we saw how each of the traffic, the single request, but landing on two different microservices. Traffic shifting, basically nothing but canary release that happens, eventually shifting traffic from V1 to V2 of the application. But the cleanup is complete now. So yeah, coming back. Okay, so now comes the part for security. So Service Mesh has been very, specifically Istio, I would say, a very known feature that has been used a lot is the security. And I also did saw some questions on mTLS. So we're gonna go through that as well. So there are some specific use cases that I really wanted to walk through as part of the security of Istio. I'm not covering each. So there is entails, of course, in there, but there is something called as authorization policy. Someone was asking about, how at what level of network does the Istio handles. So generally level layer 7, like the ingress, the virtual services, destinations, and all that. But here, here it is when it comes to layer 3 and 4. You know, basically controlling the traffic. Maybe I'll just cite some use cases which falls under this use case. Falls under the security of Istio. Suppose you want a given service account associated with a workload to only make call, maybe a front-end workload should be only be making call to backend. Network policies, of course, is something you'll be able to implement. But what if you want a given type of request? When I say type, maybe it's a get request. Okay, the front end should only be able to make get request to backend and not any other requests, right? So this kind of implementation, right? This is something, or maybe making it much more complex. Maybe you want on a particular route slash items or maybe slash API slash products, a get request on slash API slash products on a given service account. So this sort of combination of implementing security is what possible using a custom object again of Istio called as authorization policy. Okay, so it you know X basically controls network traffic at layer 3, 4, and 7. Okay, so we're gonna see a sample YAML of it, how it looks, and what all things are to be mentioned. Okay, so action, it's suppose allow, deny, audit, or custom. Okay, so I'm gonna allow and deny audit is something you can easily go through, and it's easily available to implement. What I'm gonna do in this workshop is that stands out a bit is a custom implementation of authorization policy. So what does this custom do actually? Okay, workload selector, of course, we see that, and we can also see some common example use cases as well. One of them I already mentioned, and yeah, I think the examples that are mentioned are pretty much similar to what network policies does. That's the whole reason that I'm gonna demonstrate what action custom implements. Okay, suppose you have a distributed application with 5 microservices, one of them definitely being the auth application, right? But given you need to authenticate request in each and every API calls, right? It needs to be authenticated. So is it fair to have the logic of authentication in all of the microservices? Of course not, right? There's again depends from people to people on their use cases, but given if you want to implement certain thing that your authentication and authorization logic stays at one single point, and all other applications basically redirect the part of authentication or authorization to the auth service. Okay, so this sort of use case is very easy to implement when we have Istio in place. Okay? So what this authorization policy will do is any request that comes in to a given microservice, which we're gonna decide with workload selector, will redirect first to another microservice, which is nothing but our auth application. It will do its validation. Once that validation is performed and it returns at 200, the application, I mean, the traffic will then, of course, land in the backend service. So just to repeat again, instead of the backend service actually implementing the auth logic, the request will redirect to the auth server first. If it gives a 200 from the given request, the auth, I mean the service then the call then actually lands in the backend. So what's being optimized here is you need not need to implement authentication at each layer of your, I mean, each component of your microservice architecture. So yeah, we're gonna see more to it. Let's jump back. Let's move this. The security, we'll see authorization policy. Of course, we have a README to go through. Okay, of course the common part remains the Istio and the kind setup. The manifest we'll see for Istio authorization policy. Okay. So over here, what we have done is we have implemented authorization policy specifically on workloads that have a app as movie backend. Okay. And the provider here is X all this. So this is what the action is custom. We can see over here, right? There is this action called as custom. And we have a custom provider external authorization. That's what I have named it. Rules is basically any API call. So this just for sake of not making it much more complex than it's already is, any API call that is made to movie backend workload needs to have this needs to the traffic needs to go through the custom external authorization that I have set up. I have a bit of code as well in here if I'm not mistaken. Okay, not. No worries. I do have it. Sorry. So the auth service is nothing but a simple Python-based fast API application. I'll just explain a bit of a code, okay, just to make it sure that it lands as expected. Okay. So just to make it more simple, right? What it will do is it will check for a header the way it did for the early use case, right? I have made it simpler. Maybe we could have entire JWT coming in here, landing here, and we would have authenticated. But what I'm checking over here is I'm checking if there is this role, and if that role equals admin, I'll be giving a 200. Anything apart from that, I will be turning 401. So I'm making it much more simpler. So of course we can go ahead and make it much more, safer and authenticating. Maybe taking an entire JWT and validating it and then returning a 200 response. You can definitely do that. But what I'm doing is to make it simple, I'm just checking for a role header. And if it's admin, I'm returning 200. So this is what the part of external authorization is. Okay, the single point of auth. And a simple backend is the same, the movies backend. Okay, so that is something I haven't touched at all. So this is the external authorizer. And what extra I'm doing here is I need to configure Istio, the Istio configuration to allow to add this part, to have an extension provider. So we can have our own extensions as part of Istio, and maybe an external user. I mean, sorry, my bad. An external server itself. So it need not to be in the cluster itself. It can run in anywhere. It just needs to be reachable. Maybe you can just have the service mentioned here, the port, the path, okay, and you need to mention the header as well, which you're checking. I have also included authorization in case if you want a bearer token to be in place, right? You can just come ahead and go ahead and implement that as well. Not an issue. So yeah, this is the part where you include the custom authorization server that you have built and have it handy. So once also you need to, of course, so this needs to be running somewhere. It is pointed to that. And yeah, this is the only custom part that we are doing. We are making changes in the Istio config. Rest everything remains exactly the same. We have the deployment of the authorization server in the cluster itself, right? Everything else remains the same. Okay. So yep, that should be it. And let's go and deploy it. Again, the same way of deploying things. I deploy all of it at once and we'll wait. This I've explained. If you can also see, if I come to this destination roles, gateway, virtual service, everything remains precisely this. There is as such no custom config. The only part is the external authorization and this part. So what is custom for this demo. Again, it asks for a key. Please give anything. That should be fine. Yep, our external auth server is up and running. Cool. Okay. So as I mentioned, what will happen is the request will come in first. It will first check with auth server. If auth server returns a 200, only then the request will land. Let's say in action. I'm using again the same application, of course, but if I refresh it, yes, you see there is nothing coming. Let's open the inspect mode. If we can do it and go to network. What happens if I refresh? You can see we here get 401. Okay, 401 unauthorized. So again, I'll use this header. The header is role admin. What happens if I refresh now? Yep, bingo, it's works. Yes, exactly. That's what I wanted to mention. So there's absolutely no authentication logic in place for the backend service. I did no code change in that, and you have authorization in place, right? So that's the power of Service Mesh, and specifically what I was actually fond of, right? So I could have, of course, made it production grade. What I can easily do is simply have a sign-in page, of course, that once signed in will inject the readability, maybe cookie or the token in the browser. And whenever any other further request the frontend makes, that token is present. And instead of implementing the token verification part in the backend service itself, what I'll do is I'll have the same implementation, and that auth part completely gets redirected to the authentication server. And there is no implementation or code changes required in terms of the actual microservices. This would also help to scale the auth part independently instead of worrying about the application part, right? You need so it completely decouples it out, and yeah, helps in scalability. Yeah, that would be the demo for the authorization policy. Please let me know if you have any questions. I'll just wait for a minute or two to see if any questions show up, or else I'll just move on ahead. Also, there is a script to perform test. Yeah, denied as expected. Just it's pretty fast. That script basically, curls the API endpoint without the header, and with the header, it's 200. Yeah? Fairly simple to understand. Priority is not something I should be defining here, of course. I mean, I pretty much feel it's like, when it was last changed, right? Last modified. So it it's more like an and operator rather than an or operator. It definitely has to have it instead of going through one by one. It has to have. So yeah, of course, you need to be very careful in planning that. Instead of, it's better to have all the common, changes such as you want given authorization policies, right? If we can open it again, and all the rules. It okay, top to bottom. A few mentioned over here. It's top to bottom. But if you have multiple authorization policies, that would cause a lot of conflicts, of course. Same with the ingresses, right? If you don't play it accordingly, it will just break up. Yeah, that's the case. Great. I will be cleaning up if not anything else. Okay. If no questions, I'll be good to go with mTLS. Okay. A bit about mTLS before jumping right into it. Yeah. So mTLS basically stands for mutual TLS, wherein so the way we access any application, HTTPS based application, right? It is we who verify those certificates. It's not the server which verifies that we have received it mutually. Uh, so in case of mutual TLS, what happens is the traffic that goes and comes through, all of the traffic is encrypted. Only the traffic gets decrypted at the endpoint itself. So there is no plain text traffic going even inside the cluster. Usually that not happens to be the case when there is no mTLS involved. So what people prefer, because it's just people think of that the traffic that is internal to Kubernetes. So let's not have any. I won't say any, but they become loosened on the security part of not having mTLS in place. So what mTLS actually does and how it works basically for Istio is, as I already mentioned, there's a sidecar that is injected in all of the workloads, given if it's a namespace based or if you have annotated it manually. So what would happen? So the TLS, maintaining the TLS part, it stays with the sidecar itself. You need not need to manage the certificate. You need not need to make any changes or configurations in the workload itself. Istio will come in, it will jump in, it will inject the sidecar, and boom, the mTLS is managed by Istio Complete. Right? That is basically mentioned, basically configured using a custom uh, resource called PeerAuthentication, which is again, of course, part of Istio itself. So as it has definitely, I mean, it's not, sorry for the different one. So it has three modes: permissive, strict, disable. Okay. So permissive is pretty simple as not having so it's a default one. Even if you don't have anything mentioned, it will allow non-MTLS workloads as I mean the request will be success. Okay. Comes to disable, yeah, it completes it like turning a knob off. Being permissive is basically like being tolerable to not having a sidecar. Being strict is basically says that any workload that you're supposed to be working with needs to have a sidecar running, or else the traffic would just go to failure as 403, if I'm not mistaken. Okay? So that's what the mTLS is for. So the implementation is fairly simple, of course. If I can go through the manifest, I can show you that. Okay. Yeah, that's the workload. So I'd like to also mention one more thing. Suppose you want to implement mTLS for only a given namespace, then you have it on that namespace. If you want to enable it cluster-wide, there is no other custom resource for cluster-based peer authentication the way we have for role and cluster role, nothing like that. What you need to do is you need to uh, have this mTLS mode strict in Istio system namespace. If it is mentioned as strict in a Istio system namespace, it will abide to, I mean, it will be true for the entire cluster itself. Then all of the cluster wherever the traffic goes and comes through needs to have a sidecar. That becomes mandatory. And of course, given if it's a live production workload and you enable this, we're looking for a great trouble in coming to you. It will just disrupt the entire workload. Right? So how you're gonna do is implement mTLS. You eventually start with permissive, then you monitor the resources. Okay, we're gonna see Kiali, a very great UI tool for Istio Service Mesh monitoring, where we can see the traffic. We'll see a great use case as well, where we'll see that there's a lock on the traffic that says that the traffic is encrypted. So yeah, pretty much that would be the same. Of course, again, just to confirm, there is absolutely no change in the virtual service, in the destination rules. Okay, yeah, of course. So herein as well, what we mention is the TLS mode to be Istio mutual. So whatever Istio prefers, that is what it remains. Okay. Just getting alert. Just a moment, please. Right. Okay. We don't have any questions. Great. Let's go ahead and reply. Okay. Option one. So right now it's getting deployed in default namespace, but do we have any workload? Ah, okay. So right now what is getting deployed is with support and generate Egress 1.2. I think it generates 1.3. Let me just confirm that. So by default, it uses 1.2, but we can definitely make it use 1.3. Okay. Okay. So this, yeah. So deployment is out ready. So there are some, sleep pods that I created to, roll out and check if things are working. Let's go ahead and check for to run pretty fast. Screen. Okay. Mhm. This is a complete different error. Anyways, let's. So there's one script to test the mTLS. Okay. And what it does basically, it runs a pod sleep mesh client with, so there is one pod with sidecar, another pod with not a sidecar. Okay, and both of them will curl to the backend service. Okay, current mode is permissive, injected target backend mtls, so it is trying to reach to this API from the mesh client. So this is basically having the sidecar. So although it says 404, I mean, it is able to reach. You can see the response is there. This API request, this route itself is not there, but yeah, it is getting a response as 404. It's not forbidden, or it's not like it's not able to reach. It is able to reach. The API response are a bit different. Same happens to be the case, with the legacy client as well, with no sidecar as well. I mean, with plain text is able to make the request. What if I'm changing this from permissive to strict? Okay, I manually edited it. No worries with that. I could have used from the menu as well, but yeah, just for a fast one. Let's get done. So I just edited it manually and made it strict now. So what will happen if I run it again? Okay. Yeah. So if you can see, the sidecar had the same response, right? Detail not found. Of course, that was the same the case. But if you now come and check the curl request that was made from no sidecar with the pod that didn't have the sidecar, it failed. Okay, it won't even have able to reach. Of course, it will go timeout of eventually. But yeah, this is what you get. Any workload that doesn't have the sidecar will now be, won't be able to make request to this workloads that have the sidecar. Right? That's what the MTL is. And if you can really see that, right? There's absolutely nothing to change. The sidecar gets injected, it handles the entire MTLS workflow. There's no implementation required at your end. When you see the certificate, all of that as part of the MTLS is handled by Istio. Your, I mean, your role is next to negligible as part of handling MTLS, right? So that was mTLS for you. Right. Do we have any questions? I'll just wait for again a minute or so, then I'll just jump forward to the next. I'll just press on the clean up. So before I'll make a small change. Before jumping into observability, I would like to jump into multi-cluster first. I don't see any questions, so I'll be moving ahead. Okay. So multi-cluster, as the name suggests, there are more than one cluster. Okay. So apologies. Yeah. So what happens here is the traffic flow that happens within the mesh is not limited to one cluster, but goes to and fro from into another cluster. Okay, so what it is exactly is, so a multi-cluster approach basically enables workload in different clusters to discover and communicate with each other using Kubernetes native patterns. When I say Kubernetes native patterns, so you should be able to make, you know, uh, a traffic call from just using the service DNS as well. So you need not need to mention any of the IP addresses. The service discovery, right, of Kubernetes should natively work without any changes at your code end, right? So if I cite an example, suppose a given service, maybe I'll say, product service is running in two clusters, cluster one and cluster two. And uh, there is another service, maybe you say, front end is making a call to the product service. So what you would do is basically you will be providing the internal kube DNS, resolving one, the specific cluster local, the service name, the namespace name, and service cluster local. Even if it's not in the same namespace, if it is in the same namespace, I just mentioned the service name. It should be able to resolve that, right, without any changes at your end. So here, what happens is the DNS resolving, right? The service discovery of Kubernetes works alongside Istio's discovery. And that's how it is able to, make, it should be able to land the request across the cluster. Load balancing, of course, depending upon what type of load balancing you want, least connection or maybe round robin by default. So it should be able to navigate across the cluster, right? That's what the we're gonna have the demo as well. Okay. So some of the benefits of running multi-cluster, meeting regularity or data residency requirements. So this is something that people who have been working with, I would say government-based clients, they want to given data to not escape, from a given region. It's bound to a region or to a zone. Improving fault toleration, of course, you have a high availability kind of setup. You just turn a knob and the entire workloads, basically sort of a DR thing. Already mentioned, supports disaster recovery, increasing overall resilience, reducing blast radius. So if a given region goes down, you already have one running out there, allows platform to scale beyond the limits of a single cluster. Yeah, fairly simple to understand. Moving ahead. So there are four patterns of setting up multi-cluster in Istio. Multi-primary implies both the clusters would be running. So any traffic that is coming to a given workload, if the same workload is also present in cluster two or maybe three, so it will be getting kind of load balance between them. Okay, that is multi-primary. Primary remote. So it's more like a active active and active passive kind of a thing. Multi-primary is basically active active. Primary remote is like active passive, wherein the active traffic would go to just the primary workload, I mean the primary cluster, and you maybe given a stance, you can change the knob and all the traffic goes to remote workload without any configuration code level changes. Multi-primary in different network, it's pretty much self-explanatory. The both the clusters are on a complete different network. Primary remote, again, same active passive on a different network. Yeah. So for our current use case, I'll be simulating primary, multi-primary in a different network. Okay. So the pod CIDR for both the, I'll be spinning up two kind clusters with complete different pod CIDR and service CIDR. And that is one of the, I would say, uh, hard requirement that the pod CIDR and service CIDR needs to be different for both the clusters. Although when I say multi-primary same network, I mean the VPC, if you take it in a cloud, perspective, the VPC can be same, but of course they need to be on a different. The CIDRs of the pod and service shouldn't be overlapping. That is a hard requirement that needs to be followed when you go ahead with the setup. Okay. This is the diagram or an overview of what we're going to set up right now. We're going to have two clusters and two different networks, right? And I mean, for us, two different kind networks. And how it basically works is the Istio daemon of the each cluster basically communicates with the API server of the other, so as to fetch the endpoints, the configurations of each of the service. And that is how it works alongside the service discovery of Kubernetes to be able to resolve a given domain across the cluster, not just limited, but across. Okay. And when this Istio daemon fetches the latest endpoints and it pushes the same endpoints to services of the respective clusters. So when I say it pushes to the sidecar itself, of course. So each and every request doesn't have to go to Istio daemon to check for a given, where do I land after origination of the service. Given service A makes a call to service B, right? It reads, I mean, it gets to know about it from the sidecar itself, and it originates and lands on the. So, Mohammed, could you be more clear? Like, what do you mean by stacked multi-cluster? I'm really not sure about it. So, sorry, I just jumped midway. So, the service A will make request to service B, which can be both in its own cluster and also in cluster 2 as well. So, it will be able to know about the cluster service running in cluster 2 only via through its sidecar, right? It is like the way we have, the slash etc slash, hosts file, pretty much similar to what the sidecar is as of for this use case. That it is able to navigate the traffic goes through the gateway that you see here is nothing but the east-west gateway. Okay, we're gonna see the live demo. I'm just explaining the theoretical part. So once we get the demo, you should be able to understand that, right? So study of each respective cluster reads the config endpoints of the others and then pushes those configurations to the sidecars of the respective clusters, and the sidecars have the information about the endpoints running in the other cluster. When the request originates, it goes through the records of the sidecar and then lands on the gateway of the other cluster if the service is present, of course. And yeah, that's how the service completes. Okay, so let's get started with the demo. Go to multi-cluster. Oh, okay. So here the scripts are a bit different because there's a lot of images to be pulled. So here it's like zero install kind first. Okay, my bad. I'm not supposed to install kind. I'm supposed to set up the clusters. The first, there is also a command to install kind and Istio Security, but of course we can ignore that for now. So we're gonna set up the cluster first. There will be two clusters running right now, like unlike last time. So there will be two Docker containers, of course, inside the two clusters on a complete different network. Okay, so if I can show you kind, yep, two clusters are up and running. Let's go ahead and I need to, so there are lots of images that are going to be pulled. So what I'm doing is I'm pulling it my local ones using Docker pull command, and then I'm going to load those images. So instead of the images getting pulled twice, it will just be pulled once. I already have it in my local, of course, so it won't be pulling it anyway. It will just load the image in the cluster. So what will happen when the pods will actually spin up, instead of pulling the image, they would already find the image in the cluster, and yeah, just start up. For a faster startup, I'm just running this script. Of course, it's a uh, optional script in case if it fails at your end, that's absolutely fine. I have seen it failing in Mac systems for some reason. I'm really not sure. But in case if it fails for you, absolutely fine. There's no worries. You can skip that part if it fails. I'm doing just for having the leverage of starting things a bit fast. Okay, the image loading is complete in both the clusters. Now I'll go and deploy. Okay, so I'm using this Metal LB for this demo. So what it does basically, I think pretty much every one of you would be aware that you won't be able to get an external IP address in your local system, right? If you keep the service as load balancer, you won't see an external IP address. So Metal LB is something that will be able to, manipulate the L3 and L4, and I think L3, if I'm not mistaken, to be able to provide an external IP. The reason being, because this east-west gateway needs to be, accessible from within inside of the pods. So the pods of cluster one. So it'd be able to access the IP address of east-west gateway. So that's how the connectivity gonna work, right? Unless and until they cannot reach the east-west gateway itself, there is no traffic going outside the cluster. For that very reason, what I am doing here is installing uh, MetalLB. Okay, you can just go ahead and know more about it. In respect of time, I'll just go ahead and deploy it right away. Mohammed, I think the concept of stat cluster is a bit different from a multi-cluster. Okay? So multi-cluster has completely two different control plane, and that is a concept for a different, I think, use case. So uh, being direct to your question, no, that is something not really possible to stat clusters. Okay, so MetalLB system is set up, so we will be able to get external IP when we have type load balancer. Now third script to set up Istio on both the clusters. Okay, just to mention, I'll just show you. So yeah, so if you can see, apart from this common thing that we have been deploying so far, we also have a custom value thing wherein we mention the details about the mesh that we'll be spinning up. This is for the cluster one. We mentioned that it is in a network one, right, with mesh ID one. For the cluster two, the mesh ID of course remains same, but the cluster and the network is different. Right? That's how we initialize the Istio with a custom uh, cluster name and mesh, a network, of course. And post that, we also set up east-west gateway. Okay? So this is a custom configuration, completely custom, which is needed, for the east-west gateway to spin up. Okay? Of course, you have the manifest handy with you. I'm not gonna deep dive into this because it would again stretch the time. So yeah, that's how I think I have already deployed the Ingress gateways and the east-west gateway. Let me check that. Yes, so if I do get pods in ecosystem namespace, you see there is one more pod with east-west gateway, right, running. And if I do get a service, we should be able to see the external IP is there. Of course, it's a private IP, right? It is basically, provision from the internal network of the Docker itself. So I have made some configuration changes, configs, so that this IP is able to is routable from inside the pod. Okay, so that is something everything managed from the script itself. So what I had done is basically I had chosen an IP from the CIDR of my Docker's network. Okay, so that this IP is reachable. Okay, so that those things I have already checked in for the script. That's the whole reason of why I had scripts in place, just not to get diverted a bit in depth into network, right? And in the cluster 2 as well, we have the IP address. Okay, 255.1 in cluster 1, 255.101 in cluster 2. Yeah, that's pretty much it. Okay, so very important thing is when I say that the traffic goes beyond the clusters, arena. What about the security, right? How is that even authenticated? How does that work? So what happens basically is the initial authentication, right? What happens? The way service account authenticates, right? We have a token of that. So each and every request that goes to this east-west gateway is authenticated and authorized as well. Okay? So for that, what needs to be done is we have to create a secret, right? The way we the service account authenticates, right? With an availability token, right? So that secret needs to be created, and each and every request that is being routed to east-west gateway, the sidecar would be the one which will be injecting and working everything that is related to authentication authorization. Again, you need to be configuring anything apart from that in your application, of course. Yeah, so as just mentioning, the authentication and authorization path is, of course, given the most priority, and it is being handled at Sidecar and East-West gateway itself. So for that, we need to run this script. So what it does basically, this it's certificate-based authentication. Of course, the certificate, the Istio daemon of cluster ones needs to trust the certificate that is being issued from cluster two, and vice versa as well. So for easy use case, what I have done is basically I had used the same certificate in both of them just to avoid longer work. Of course, you can have a common certificate CA, and from where you can generate certificate for each of the cluster and then use it. That's the actual, and you maybe integrate cert manager in place, and you have a custom CA. You get them generate a certificate, then use it. That's the production way of doing things. As this is a workshop, and fairly should be easy to work around with. So that's what I've done so far for easy uh, usage. And again, some reloading of images, options skip totally. These, if it's not working at your end, absolutely no issues. Yeah. So image loading is complete. Now what I'm going to do is I'm going to deploy. So, okay, going back to a bit on this. So this is a sample application, microservice-based application that I'll be deploying. Okay. So it has 5 components and 3 infrastructure related things. I mean, it basically includes the database, Postgres or Redis, DB for auth related logic for storing some caches, and RabbitMQ for this distributed communication, serverless basically communication. It's not async command. Async communication. We have RabbitMQ. Okay, let's go back and deploy the app. So what I did was I deployed the app only in cluster 1 as of now. Okay, that's done. As simple as that. We'll see in the simple by namespace if the apps are running. It will take some time for all to come up because it requires Postgres for to be up and running, like one of the dependent components. So once it is up and running, all others should also, yeah, it's already running, right? I should be able to see the app as well. Let me see. I should change. Yeah, the app is changed now. So a fairly a small e-com app that I have here. It's you can just navigate through all this app, uh, kind of a Potterhead I am. So yeah, trying to. So fairly a e-com app. I already showed you the components. You should be able to maybe register and give anything as name. Yeah, that's it. I was able to register. Basically, auth is what I wanted to mention. Then sign in. Just please ignore this. Yeah, I was able to sign in. Then I should be able to add to cart. So a very minimal and functional e-com app that I have here. Reason for that is to show actual implementation rather than just some sample demo. Okay, so I have it in cart. I'll be able to process to checkout. Yeah, of course, all this async complete full stack application is what I have. So what I'm gonna do is, so as of now, all the application components are just in cluster 1, nothing in cluster 2, no cluster wide communication right now. Okay, so what I'm gonna do is deploy just one component, the product service. You can see right here we have the product component. We're gonna deploy this product component to cluster 2. Yeah, was that easy as just running the script? Right. So now I have deployed product. So product has a hard dependency on Postgres database, of course, to fetch the Postgres app. the data cost, and also on RabbitMQ. Okay. I think it should already be running. Okay. We see crash to backup. Let's see the logs of the product service. Okay. So if you can see over here, it says an error and it's not being able to reach the simple button. But as per our current setup, I have already authenticated, the service, the between the cluster certificate thing that I mentioned. Even so, but it is not able to route this request. It is not able to find this. The reason for that is if you go and check the service in cluster 2, there is no one. There is no service for Postgres. Okay. But when I say it should be able to, because the Postgres is running in cluster 1, you need not need to have it in cluster 2, right? That was the whole reason of having this cluster setup. I did not need to run everything in everywhere. Just run some things in some cluster and I should be able to navigate. Reason for that is the service discovery, right? It starts from Kubernetes first and that gets handed over to Istio. So there is no service in first place for Istio to even take account of. Okay, what I'm saying is what I need to do here, there should be a Postgres service, just the service, not the pod itself. Right? So so what will happen, even though there will be no endpoints in cluster 2, but Istio will be now aware that there is a service. So only then the sidecar of cluster 2 will have any clue to be able to route a given service. If the service itself is not there, where is it even gonna route? That's the first message. First, Kubernetes needs to take in the service, then Istio is the one will take control. So what I'm gonna do, I have for the very same reason what I did, I had commented it out in the customization YAML. You see, both the services have been commented out. Yeah. So let's go ahead and deploy it right again. So now when I run the deploy to cluster 2, the services will be created right now. Okay, nothing apart from that. So now if you see the product service, it will take some time, and what we'll see is, so as now the Postgres service has been created, so this, so there is a DNS resolution that is happening. Of course, not landing anywhere for Kubernetes, but Istio now knows that there is a service present, right, in cluster 2. So give it some time, it should go running. Just go ahead and delete the pod if that is the case. Post deleted it and it's initializing. Yeah, went to running state. Eventually, would have entered into running state, but just for partitioning things a bit up. So is there? So if we can clearly see, there is no other pod running in cluster 2, right? My command itself, if you by any chance feel that I'm bluffing, of course not. I'm using the context to check for the pause in cluster 2, right? There's absolutely nothing running in cluster 2 apart from the product service, but still, as it has a hard dependency on Postgres and RabbitMQ, those are running in cluster 1, but still it is able to communicate. You see, I just have the services over here. I don't have the pods. There is no pod for RabbitMQ or Postgres. It's all of that is running in cluster 1. So, is the application still working? Let's find out. Let's go to the home page, perform some refresh, couple of refresh. Do we see? You can see there have been some API calls that landed into cluster 2's for product service. What if I completely scale down in the product service in cluster 1 itself? Just to be sure, I'm just giving the context as well, right? To show you that what I'm gonna do is I've scaled down the entire product deployment in cluster 1. So there won't be any product here running. The only product is running is in cluster 2. So now what will happen? Even so, there shouldn't be any change, of course. So yeah, that's what the multi-cluster does. So if I can give you a brief of what is being done here, okay. So as per our current implementation, the request comes in from Istio Ingress gateway from the virtual service and destination rules, whatever I have, goes to the pods of, like, depending upon the request being made, right? And if a given request, so as per this use case, it is being, load balance between cluster 1 and 2 for the product service, because the only service that is there in cluster 2. Had we have the entire thing in cluster 2, there would have been the same case, of course. Okay. So it load balances between both the clusters, and if given a service, okay, a given pod is not present, in a cluster 1. So all of those requests goes to from Ingress gateway to the service and directly enters the east-west gateway, because there is no port to communicate at all. Even Ingress gateway has the configs of where it should be routing the request, right? So that's how the traffic has been going so far, right? Eventually, it was load balancing in between product in cluster 1 and product in cluster 2. But as there is no product in cluster 1, all of the requests got migrated and landed in cluster 2. Yeah, that's what we have in for multi-cluster. Right? Do we have any questions for multi-cluster? Please let me know. Mission controller can. Not really sure, Mohammed. Maybe I'm not a bit clear about what you're asking, but yeah, if it could be more clear, maybe I can ask. Yeah, I'll be cleaning up then. I have anything for cleanup? I don't think so. And can just go ahead and delete the clusters itself. Yep, I'm good. Okay, moving ahead with the observability part. So what I have done, so there are some, so when Istio, by default, it emits matrices for, all the sidecar traffic that it intercepts. So I'm not going to tell much about it, rather, just going to deploy and then show you right away. Okay. So for this part of the demo, I'm deploying the same microservice-based application, the ecom one. Then so there are some custom dashboards and matrices which are supported from Istio, where we can visualize all those things in one of the open source framework, open source software called Kiali, which gives a very good demonstration of how the traffic flows happens, and gives a very great UI in fact. So that's what I'm gonna really show to you. And respect of time, I won't be able to deep dive much, of course. But yeah, you can definitely go through it and have your findings, and I'd be happy to answer to that. So what I'm doing here is I'm installing Kiali dashboard, Grafana dashboard, and Prometheus as well. And as I already mentioned, Istio emits its own default matrices using which we should be able to get some good visuals as well on Kiali and Grafana. So it's the same application, of course. I'll just, if I go straight away and just refresh this, the application is not up yet. Wait for some time for the pods to come up. Once the Postgres comes up running, things should be stable. Yep, it's pretty stable. I should be able to see product not up running. Waiting for the 2x2. Yeah, it's up. So yeah, the same application. So I'm gonna do some refreshes. I'll just okay. So the reason I'm doing this is to generate some traffic so that we have something to look towards, like in the dashboards, right? So I'm just randomly generating some traffic. Yeah, we are pretty good. So I have deployed the same application and have tried to simulate some traffic. Then we are gonna open the Kiali. This is what the Kiali UI looks like. Okay, so we're gonna go to traffic graph, with namespace, simple by. Okay, cool. You can see it already looks pretty cool. I'll just have some animation. Yeah, you can see, my bad, apologies. So we can also drag and drop this, and I should be able to zoom it a bit. You can see you get a very good visual of how things are working, right? And right now it doesn't show a log. Let me have security enabled. Yeah. You can see there is this log, you can see, right? If you can zoom it out further more, you see this log. This is what the mTLS is. I mean, it is visual representation is what I wanted to mention. This triangle is basically the service, the Kubernetes service. This is the actual pod, the workload. Had I have multiple pods, you would have shown multiple over here. Just have once, one. If you can see, there is also some error initially, because it was not, the front end was down, right? So you see that red line also going on. So you also see over here, there are 4.91% of 400x, no 500s, only 400s. So this is what I was mentioning, the observability part, right? So I'm not deep diving into the actual matrices what Istio supports, but yeah, you get a very great representation of how things are working, right? And so of course the entry point is the Ingress gateway, and the traffic goes through all of that. But it also builds a very good dependency graph of how things work, right? So all of this. Do we have any questions for this? It seems pretty straightforward and simple. Let me know if you have any questions. Okay, we can also go to the Grafana. Let's see what our dashboard. So all of this is basically, in default provided from Istio itself. I haven't configured anything as such. If you can even go, I can show you the script of what I have deployed. Uh, so, scripts on the infrastructure. If I go here, so I've used the sample add-ins. I haven't configured anything raw as such. Okay, so it's all the default whatever is supported from Istio, not the Prometheus add-on. Of course, it is fairly simple. If I can show you the Grafana dashboard, it has some default dashboard that are supported from Istio. This we're gonna see right now, and even the Kiali, right? I haven't configured anything custom apart from what they docs is. I've just simply applied it. You can open over here. So if you can see, there's a lot more things to mention. There's a control plane dashboard, lots of things to, of course. This is when is the UTC time, connections, events, right? So the events are basically, when I mentioned, right, the IstioD basically is the brain of the Istio Service Mesh. It manages the entire data. It pushes to the sidecar, right? The push over here is what exactly it meant, pushing the data to the sidecars. Memory allocation, CPU usage. Let's go to some of the dashboard to see the workloads. Okay, so if I can simple by, this is the auth workload, right? Then maybe for product, right? You can see it says a lot. In fact, what all incoming requests were made to product from like maybe from any of the services. You can also see mTLS log as well, right? Given if it was from some other sources, the log wouldn't be visible, of course, right? You see the mTLS log as well here. gives a pretty cool visual of what all things could do. Yeah. For order, of course, nothing. Didn't go to any order service. Notification, yes, a bit spike. Yeah, but of course, you can play around with the app. Then, yeah, you see the entire board filled with data because I don't have enough data to show the dashboard. That's the reason I skipped the observability to the last because I really don't have data to simulate on that. Apart from that, yeah, you have this 90, it's not getting populated, maybe for some reason, I'm not really sure. Even not so. Okay, no worries about that. Okay, yeah, that was pretty much about observability. I leave it to you again, to please go through this and have your own custom implementations, create, experiments with this. Should be good. Can play with all the knobs and custom whatever is present over here, right? And there's the sent bytes. What about received bytes? There's empty graph. Anyways, I think the traffic is already, I think there. Yeah, because there has been no traffic so far in last 1 minute, we don't see any. So the idle nodes, here it is. The simple by the Istio system. Right? Here you see the idle workloads. Okay, seems to be what I wanted to talk about observability. Uh, what I'm planning is to have, go through the troubleshooting at your own end and reach me out if you want to know anything more. So that is something I'm, giving it to you. I have the entire thing mentioned over here. I have mentioned the exercises, what all things can go wrong, how you can debug them, right? You can set up the cluster and clean up the fairly simple part, which I've been doing so far. But I leave this to you so that get a learning of something doing it raw at your end. I'll be waiting for some questions. If not, then I think we should be good to close this.
Yeah, wow, Sayed, that was amazing. Um,
Yeah.
I'm sure our audience now knows the actual power of Service Mesh, the things it can do with Istio. And the traffic management part, I found it really exciting the way you used Hollywood and the Bollywood references.
Right, right. Yeah.
Yeah. Yeah, so you pretty much covered everything from security to multi-cluster setups, networking side of things. Also, the observability part you just discussed.
Right.
Uh, so yeah, with that being said, thank you everyone for joining today. And we also have lots of such deep dive contents all available on our platforms for free, obviously. And I really appreciate folks to check out our new website. Now it has real executable roadmaps that you can, start learning from day one. And also the concepts and workshops such as this goes without saying. So yeah, it can be a good place to start or to come back whenever you feel stuck. And thank you, Sayed, for this amazing session. We hope to host you again in the future as well. So uh,
Thank you, pleasure. The pleasure
all
has
right.
been mine to be in this platform. Yeah. Thank you so much.
Thank you, Sayed. Okay, we will end this session now in three, two, and one. Thank you, guys. Bye bye.
Bye.